Derivatives for so far, we've done single functions, right? X to the fifth. You've found derivatives of sums of two functions, like x to the fifth plus, let's write it separately here, x to the fifth plus 3x squared or something like that, right? This is the sum of two functions. We've looked at the difference of two functions. If you have the sum or difference of two functions and you want the derivative, you just look at the derivative of each one separately, right? If you want the derivative of this function as a whole, you find the derivative of this plus the derivative of this separately. The same goes for the difference. You found that when you had the product of two functions, x to the fifth times sine x. When you have the product of two functions, can you just say it's the derivative of this times the derivative of this? No, you need the product rule for that. Okay? This is a product of two functions. You need the product rule. But we can do that. If you have a function that's the quotient, same thing, right? X to the fifth over sine x. It's not just 5x to the fourth over cos x, right? It's not just the derivative of each one divided. You need the quotient rule. But what we haven't done yet is the composition of two functions. Okay, we've looked at the limit of compositions and things like that, but we haven't done the composition of two functions. So composition meaning, here we have x to the fifth times sine x. We haven't done a function that is something to the fifth, but the something is sine x. Like x to the fifth times sine x, or x to the fifth divided by sine x, this is sine x to the fifth, or we could do x to the fifth and then the sine of that. Okay, composition of functions. For the product of two functions, you needed the product rule. For the quotient of two functions, you need the quotient rule. So for the composition of two functions, you need the chain rule. It's right here. Look, see, I mean, the composition rule. No, you need to, well, that's what it is, basically, right? It's when you have the composition or the chain of two functions. And it helps to think of this like a chain of two functions. When you first learned about functions and when you learned about composition, well, when you first learned about functions, if you have this function called sine, you put a number in and you get a number out, right? You put in some number, you get a number out. If you have the composition of two functions, it's putting two things together. You put in an x value, you find its sine ratio, you get some number out here, right? And then you put it into another function that says raise that to the power of 5, right? Whatever you get, put that in here, and you get a number out, right? This function here, you pick a value for x, you put it in, you find the sine ratio, you get that number out. So if you put pi over 6 in, the sine ratio is 0.5. You put the 0.5 in here, and whatever the fifth power of that is, 0 point something. You get that number out. That's what a composition is, right? There's an inside function and an outside function. The way you write it is the function you do first is inside, right? Okay, you put that inside the brackets, right? When you write sine x to the fifth, this is the first function. We're going to call that the inside function. Okay, inside function is sine, right? The outside function here is, and I'm not going to put an x after it, I'm going to say sine of something, right? Because the something could be whatever. The outside function here, outside function is, what's the outside function there? Something to the power of 5, right? When you put those together, you do this, right? You take this function and you make it small, and then you put it in here, right? Okay, do you want to see that again? Instant replay. It's not slow motion instant replay, but it's a replay, right? You make it small and you put it in there. It's two functions you're putting together. That's what a composition is. You're composing them, right? If you're a composition in music is putting notes together and making something, right? Composition. If you write a composition in English, it's putting words together to say something. This is putting two functions together. Okay, compose means to put them together. Yes?
What's the difference between the composition and a product?
A product would be as if we did this. We didn't make this one small. Well, the small has nothing to do with it, but putting it beside each other and saying times each other, right? If you wanted the what you do in grade 10, it's not a chain of functions like that. It's not put a number in and get a number out of the first one and then take that result and put it into the second one. If it was a product, it would be this. It would be put this one over here, put pi over 6 into both of them, right? If it said sine x times x to the 5th, if it was multiplied, it would be put pi over 6 into each of them, get the number, whatever, pi to the 5th over some big number here. Like, get the answer to each one and then multiply these together. The difference is that you put a number into one, you get the result, and then you put that result into the next one. Okay, so that's kind of the key here. When you have there's 4 things here that have x squared and sine x involved. Not all of them are compositions, right? This one is a product, right? X squared times sine x. You would put the x value in and then multiply the results. This is a quotient, right? X squared over sine x. You'd put the x value into each one, then divide them. This one is a composition, right? Composite function, right? Composite, compose. It's a composite hockey stick or tennis racket or something because it's made of several materials put together to make it really strong but still flexible. Composite function. Which two functions are being composed here? If you had to write it, the trig stuff, for some reason, mathematicians have developed this notation that it almost seems like it's just designed to confuse people. But what does this mean? Yeah, if you write it like that, it means square the x and then do the sine, right? So the inside function is squaring something, right? The inside function is something squared. Outside function is sine of whatever, right? Those are your two functions involved. The last one, even with the 2 in a slightly different place, it means something different, right? What does this mean if you wrote it the proper way with brackets? Sine of x, then square it, right? In this case, the inside function is sine of something, and the outside function is something squared, right? So the difference is this thing, you make it small and put it in there, right? Whereas the other one, this one's the one that goes inside, right? That's the function that you shrink down and put in there, right? So first you do the sine of something and then you square it. The other one you do it the other way around. Okay? This went away. Does that make sense? Yes, no, maybe? We haven't talked about what the chain rule is yet, but we have. That's a pretty important basis to have before you start talking about the chain rule, just understanding what functions, how they're put together.
Isn't that like sine x times?
It's not. Well, you could, for this one you could, like sine x squared, you could actually get around using the chain rule by just thinking of it as sine x times sine x. And in fact, when we first do it, we're going to do that. We're going to do it 2 ways and see the difference. But absolutely, right? If you want to see what the derivative is for that, you could make it into a product, right? Just like some people avoid the quotient rule by a similar idea. Like you can try and avoid certain rules by doing things. If somebody says sine x divided by x, you could change this to sine x times x to the negative 1, right? This is a quotient, but if you're just philosophically opposed to the quotient rule, you could write it like this and then use the product rule. So you could do the same thing here. If you think of this when you say, well, I could avoid the chain rule by doing this. The chain rule is actually easier when you get it than using those other ones, but there's a list of functions there. Try and write out what the inside and the outside is. I like the idea of just using brackets, like sine of something, something squared, tangent of something. I'm going to pause this while you try to do that, and then we can have a look in a second here. Okay, well, for the first one, if you do write it out this way, the way it should be written, if mathematicians wrote things properly, tan x, all of that squared, the inside function is obviously tangent of something. The outside function is something squared, right? The second one here, inside function, something squared plus 9. The outside function is cosine of something. This one here, inside function, something squared plus 10. Outside function, something to the 15th power. No, they're not the same somethings. You're right. Very good point. Can we suspend all the conversations for a little bit here? Inside function here, sine of whatever's inside there. Outside function is tangent of that. Okay? This one is not a composition. Okay, as soon as a function involves more than one thing here, like square root, plus 5 or minus 5, all this, the inside function here, this is the inside function, right? That's the inside function. Because it helps to think about how you would write it on your TI-83, if that's the calculator you have. It would look like this on a TI-83. It would be square root, there'd be a bracket, right? There'd be brackets there. 3x minus 5, that's how it would look. And then there'd be a plus 2. Does that make sense? That's how it would be written on a calculator. The inside function is 3 times something minus 5. The outside function is square root of something plus 2. Okay?